All right, Mr. Barr here, and this is the practice test for linear equations. Linear equations. So let's get started on this. What is the average rate of change? Rate of change is a fancy word for slope. So I find two good points. I've got a good point there, and I've got a good point right here. So those are the two good points I'm going to use. And then I'm going to draw in a slope triangle. So I can go from here to there. Looks like it has a rise of 50 and a run of 1, 2, 3, 4, 5. So it's 50 over 5, which would be 10. But I look at that line, and if I write my name on it, Mr. Barr, it's going downhill, which means it's a negative slope, so negative 10 on the slope. All right, we're going to graph this guy. It's in slope-intercept form. So I'm going to start at negative 4, and then I'm going to go down 3 over 2. 1, 2, 3 over 2. There's the line. This one is in standard form, so I'm going to do mini equations. I'll go 2x equals 9. So if 2x equals 9, x equals 4.5. And I'll do 3y equals 9. 3y equals 9, so y equals 3. So my intercept is at 3 on the y and 4.5 on the x. Then I connect the dots. All right, on this one, how do I graph this? I start at negative 5 on the y-axis, and then I go down 1 over 4. Start at negative 5 on the y-axis, then go down 1 and right 4. That looks good. Graph the following equation. This one, I need to start at 1 and then go down 5 over 3. Start at 1, go down 5. 1, 2, 3, 4, 5 over 3. 1, 2, 3. This one, I need to create the equation for it. In order to create the equation, I need to find the slope. So I find two good points. Two good points. Count the rise, which is it's going by 40. So 40, 80, 120. Count the run. 500, 1,000, 1,500, 2,000. So my slope is 120 over 2,000. So my slope is 120 over 2,000, which is 0.06, which you can't see. There we go. And my y-intercept is right here at about 100. So I'm going to put it all together now. So y equals the slope, 0.06x, plus the y-intercept, which is 100. I'm going to buy bananas. So bananas are $1.25, and apples are $2.75. So $2.75 times the number of pounds of apples plus $1.25 times the number of pounds of bananas equals the total, which is $35.50. Swimming and running. She swims for X hours. So here's her speed of swimming times number of hours swimming plus speed of running times number of hours running equals total distance. It costs $5 to get into the fair, and each ride costs $1.50. So total cost equals $1.50 times the number of rides plus $5 to get in. And if I'm going to graph this, I'm going to start at 5 and go up 1.5 and over 1. So let's find the graph that matches this. Start at 5, go up 1.5 over 1, up 1.5 over 1. So this is the graph that matches up. This doesn't make any sense, this negative graph. This one, I start at 5, but I'm going up 1 over 1, up 1 over 1. I need to go up 1.5 over 1. And graph D, you can't see it, but it doesn't make any sense because it actually starts at 0, 0. All right, let's actually get these answers into Edulastic and see if I get 100% on this. Practice test, start it. All right, that number 1, we said it was -10. Number 2, start at 4, go down 3 over 2. This one, the intercepts are at 3 and 4.5. This one, I said it was D as in dog. This one, start at 1 and go down 5 over 3. Down 5 over 3. This one, create the equation, and I said it was y equals 0.06x plus 100 for the y-intercept. Number 7, 2.75 times the number of pounds of apples plus 1.25 times the pounds of bananas equals 3550. This one was Sx plus Ry equals D. Create the equation. Cost equals 1.5 R plus 5. And the correct graph was A. How did I do? 100%. Okay, so both these edge elastics are ready to go. Thank you for watching. I'm stopping my video.